Python your preferred language? Is Python okay?
Could we go with C++?
We can go with whatever you want. Let's just switch it here. Let me switch it for you here. C++, I think it should be okay just as is. Let me see. Let's run this. Well, we won't really be running any code today, but okay. Looks like it works. Any other concerns before we start?
No, I think that's good. Thank you.
Okay, very good, very good. All right, so let's just get right into it then. Yeah, so welcome to the mock interview. The format will be actually we're starting right on time today, which is pretty nice. The format will be it's going to be an hour long. Typically speaking, we'll have like 5 minutes, 10 minutes at the start for like introduction and such, but we'll just skip that today. We're gonna get right into the mock. You'll have about 45 to 50 minutes or so to answer the questions. I will help you control the time, and then after that, instead of like other questions, we'll just go direct to feedback. And of course, if you have any concerns or kind of questions you have for me, then we'll talk about that as well. Okay? How's that sound?
All right. It sounds good. Thank you.
Perfect, perfect. Okay, so let's take a look. So for today's question, I'm going to dictate this for you. Feel free to pause me or ask for any clarifications as needed. Okay, so today's question, we're going to be talking about the best time to buy and sell stocks. Okay, so I want you to write me a
All right.
function called max profit. All right, and it's going to take in a vector of integers. Okay, and the integers represent the price of a specific stock on that day, right? So index 0 will be the price of the stock on day 0, index 1 will be the price of the stock at on day 1, etc. Okay, and the rule is that you are, by the way, you can take notes in the editor, that's totally cool. um, and the rule is that you need to choose one day to buy and one day in the future to sell, and you are to return the maximum profit that can be made from this one buy and sell. And if you can't achieve profit, then you just don't buy and you don't sell, and then your profit's zero.
Okay, so one day to buy, one day to sell. I return the maximum profit, and if I can make profit, then I return zero.
Yeah, which is implicitly the case where you never buy, right? If you never buy, then you make zero profit.
Right, okay. Never buy. All right, sounds good. And then, right, so then should I start out by like explaining my.
Yeah, so if you have any thoughts about how to approach this problem, let's hear that. If you have any like concerns about the problem description, let's hear that. Otherwise, like for example, if you have any like immediate thoughts about how we want to handle this, any concerns about, for example, edge cases, anything like that, that would be great to kind of bring up. Um,
Right,
but
okay.
this is meant to be pretty open ended. So if there is if you have a algorithm you want to go straight into it, then yeah, let me we can just go straight in. That's not a problem.
All right, sounds good. Um, right, so there's the vector of integers that we are given. So that's the price of stock on each day. To get the maximum profit, then we would want to buy on the uh, highest or lowest day and then sell on the highest day.
Yes, yes.
And then I guess the issue would just be ensuring that we are buying before we sell. And so I think we can do that with single pass through the vector. And
Okay.
uh, right, I think we should be able to record the maximum or yeah, minimum and maximum that we encounter through the loop, ensuring that the is after, or the maximum is after the minimum.
Mm-hmm.
Okay. It's alright if I think as I code.
Sure, sure. But before you start, I want to just clarify one thing. So you said maximum minimum there.
Yes.
Is is a max? Okay, can you be a bit more precise on what you mean by maximum minimum? Like, is the maximum value in the array always guaranteed to appear after the minimum value?
Uh, no. So we would have to ensure that the maximum that we're choosing is the maximum uh, after our minimum.
Okay. Okay. I think that's a reasonable foundation to start, but we can definitely clarify things along the way.
Okay, cool. Right. Uh,
You're talking about a one pass solution here, right?
yes.
Is that going to cause you trouble when you think about like how to get this thing started up? Like if you're not sure how to do one pass, we can start with a two pass and then move towards one pass.
Right, I see. I think, so I think the main issue here is that we have to ensure that the maximum is coming after the minimum. So rather than recording both the current maximum and the minimum, we could only record the current minimum value. Right, and can set that to is our int max, or we could set it to our first value here,
Okay.
and then as we iterate through the array, we could take the difference of each current price or of each date, and then record our maximum profit. So we would be iterating each price and prices. Our profit would be equal to the maximum profit that we have currently, and current minus current minimum. And then we can also make sure to place our current minimum with the minimum price that we have, and then return the final profit. We also have to make sure that if our array is empty, then we just return 0 so that we don't
Okay.
access invalid element.
Okay.
And yep.
Okay, should we do a walkthrough?
Yep.
Do you want to come up with a test example? Or do you want me to provide them for you?
Uh, sure. I think if you could provide one. Good. Right, so then I just explain what the output would be.
Yeah.
All right, so we would start with 7, and our minimum would be the 7. Profit starts out at 0, so for the first one, it would just be 0, because we'd be taking the difference of the first value.
Okay.
Profit stays 0, and then we go into 1, and the profit would still be at 0 because 1 minus 7 would be less than our current profit, and then, but in this case, our current minimum would change to 1. That would be our buying date, or buying price. And then we go on to 5, and from there, our 5 minus 1 would be greater than our current profit, which is 0, so we get 4, so our current profit would be 4, and our current minimum would still stay at 1. And 3, our profit would stay the same since it's less, and at 6, the profit would increase to 5.
Mm-hmm.
And at 4, it'd still be the same, so our final profit would be 5.
Okay. Final profit being 5. Okay.
Yes.
Okay, and then can you tell me what would happen if, for example, the array was like all decreasing prices?
Then in that case, our initial profit is always 0, so and if it was decreasing prices, then the price minus our current minimum. So our current minimum will always be larger than our price since they're afterwards. So our profit would just end up at 0.
Okay. Okay, that sounds good to me. Let's talk about the time and space complexity of this function, please.
Right, so the time complexity, we're just doing a single pass through the loop, so the O(n), where n is the size of the input vector. And space complexity would be constant since we are only using these 2 variables.
Okay. Okay. Sounds good. Are there any other concerns with this limitation? Otherwise, we'll move on to the next question here.
No, I think that's it.
Okay, sounds good. So we'll build upon this question, but it's a separate question now. So this is a follow-up to this question. So we won't be modifying this function anymore, but you can call it as a helper if you need. Okay.
Alright.
Okay. So for the so the same premise, you're given a one-rated function, which given a vector of prices, we want to again find the best time to buy and sell a stock. Okay. However, there are some other. It's a different premise now, which is that now you can hold at most 1 share of the stock at any given time, but you can sell it. But you can buy it and sell it on the same day as needed. And the main difference here is that we still want to find the maximum price, but the main difference can be that you can buy and sell multiple times. But you can still only hold 1 share at a time, okay? But you can buy and sell multiple times throughout the time period, okay?
Okay.
So before we kind of dive into that, let's just take the same example here, and
Yes.
I want you to walk through it and tell me in this new regime what the maximum profit would be.
Right, so in that case we could buy at 1, sell at 5, so we would get 4. And we could buy again at 3 and sell at 6, so we get 3 more. So we have a max profit of 7.
Yep. Yep, that's right.
Okay, great. Great.
So what are we thinking about this one? Are we thinking
Uh,
about it in the context of the first one? Are we thinking about it as a new problem? How are you approaching this one here?
I think that mm, I guess we could still keep it in the context of the previous problem where we still want to do the same thing where we are buying at the smallest and selling at the largest. Or I guess it would be a bit different because we can sell much earlier. So the range in which we consider the maximum would be, I guess, not till the end of the array, but until the next minimum value we can find.
Yeah, that's one way to put it. I think you're on the right track. Yeah.
So,
So one thing to note here that I'm not sure if you caught, it's actually very important to the problem, which is that you're able to buy and sell on the same day.
right. Buy and sell on the same day.
So buying and selling the same day implies one thing, which is that you reduce the list of numbers of prices into a list of pairs of options. Right? So consider this. Consider that we have a price, and let's just go. So let's do a simple. So price is 2. Let's call it 7. Yeah, 715 is fine. So 715. So let's consider that these are our prices. Okay.
Okay.
Actually, let's do it 517. Okay. So consider. So this is not optimal, but you consider the fact that if you buy on 5 and sell, so buy on 5, sell on 7, this is equivalent to, right? Buy on 5, sell on 1, and then buy on 1, sell on 7.
Right.
Right now, this is not optimal, obviously, right? But I'm just telling you that this is equivalent.
Yes. Okay. Oh, okay.
How are we feeling about this one so far?
Uh,
What's the current hesitation here? I wanna know what you're thinking of. I wanna know what you're concerned about right now.
right. So I guess it's trying to determine each peak and yeah, I guess each peak and dip to each min and max to actually I guess how to determine which one is the current min and max.
Okay.
Because
Well. So this is what we're getting at, right? So, if you're looking
Yeah.
at let's take a series of these numbers, we don't really need to know what the min and max are because we can just simply look at pairs of numbers, right? So we can consider 5 and 1 in a vacuum, and we can consider 1 and 7 in a vacuum. And if you make optimal choices for those two pairs, you have made an optimal choice for 517. Does
Right.
that make sense?
Uh, yes, I think so.
Can we think more about this example here? Right. So let's consider that you have some numbers before 5. Like let's call them x, and this might be like many
Yeah.
numbers, right? And your many numbers after 7,
Yes.
right? So I'm gonna posit that so we can just keep this here. I want to posit that let's say we have a function called max profit, right, which we do. I mean, we're gonna make another one, right? So I'll just make this like old or something, right? So I make a posit that if we have a function max profit, let's assume it's correct. Let's assume it's correct, okay? So I'm gonna say max profit of prices 2. Okay, this equals max profit of xxx plus max profit of 517 plus max profit of y. Okay, this is what I'm going to posit. Okay, and I want us to think through why this is the case. Okay, so let's assume that xx, we can assume it's any numbers. Let's say if it's a worst case, they're all decreasing values, right? They're all decreasing. Then in that case, this would be 0. Like we wouldn't buy and sell at all, right? So
Yes.
that's a pretty obvious case. However, let's say that the number before this is like 1 or something. So we want to be able to buy from 1 to 5, right? Buy on 1,
Yes.
sell on 5, right? This is basically equivalent of saying, we have some optimal solution for the previous numbers, and we want to be able to identify this pair as being good, right? But the thing is I have arbitrarily split this up. Like it doesn't matter. Like it could have been like this, for example. I've just arbitrarily split it up. So let's look at this.
Yep.
So let's change it to x. So let's look at this pair over here. So if I say we have, so let's say we have max profit. Let's do it over here. So let's have max profit 517. This is equivalent to max profit of 5 and 1 and max profit of 1 and 7.
Yes.
Okay, because we need to make a decision if we want to buy and sell. Like, do we want to buy on 5 and sell on 1? Do we want to buy on 1 and sell on 7? Right? You can't say, for example, I want to buy on 1 and sell on 5. That's not valid. Right? But buying on 5, selling on 1 is valid. So you can think of this sequence of numbers as the sum of the optimal choice for all the pairs within all the pairwise pairings within the sequence. Right? So for example, in this case, max profit of this would just be 0 because we wouldn't choose to do that, right? We wouldn't choose to do that. And then 1 to 7 would be 6 because we would choose to take this pair.
Right.
Does that make sense? And so therefore the max profit of 517 is 6 because we have broken it down to its constituent pairs.
Right.
So can we think about it from this perspective? Like, how would this change, for example, if I added another number, like let's say 9? How would this change? Can you walk me through the same logic and tell me how that would change?
So 5 and 1, so if you split it again, it'd still be 0.
Yeah.
And 1 and 7, you still have your
So that's
6.
over here. Yeah.
7 and 9, you can get 2.
Yeah. Do you want to put that over here?
Right.
Yeah.
Whoops. And you get 2 as well.
Yes. So what does this tell you? So that's equivalent to buying on 1 and selling on 9. Yes, it's equivalent to buying on 1 and selling on 9 because that's 8 as well, right? But the difference is that now we don't need, like when we consider the 1 and 7 pair, we don't need to consider 9 at all. We know that it will be correct if it was considered because we have this term over here.
Right.
Right. And then okay, so let's copy this again. So let's say what happens if instead of 9 this was 6. Can you walk me through this logic? So then what would happen?
Then in this case it would just be 0 again. And so the max profit would still just be 6, which is equivalent to 1 and 7. So I guess that means that we can just go through the entire array, calculating each pair, and just adding all the profits.
Mm-hmm.
As long as, yes. Right. Oh, okay. Right, I see. And that would just be with a single pass, right? Okay. So to implement that, I think that's all we would have to change then.
Okay. Can we walk through the examples, or one of the examples that or you can make a new one, up to you.
Sure, I guess we could just go through this one again. Then we would start at 7, and the profit would, we would add to the profit the 1 minus 7, or maximum of 1 minus 7 and 0, which was just 0, so our profit would stay at 0. And then we would go on to 1 and 5 pair, where we would be able to add 4 to the profit, go into the 5 and 3 pair, still just 0. And we could go into the 3 and 6 pair, which would add 3. So our current profit would be 7. 6 and 4 pair, which would just be 0, and it should end right there. And we would return final profit 7.
Okay. Are there any concerns with the indexes?
So we would be ending the loop at 6 here, where I is 6, and we would be accessing the 4 with I plus 1, so should not
what is prices outside in this case? So there'll be 6.
So price of size minus 1 would be
5.
4, but I would be less than that. So right. Yes, size minus 1 would be 5. And
Okay.
so I would end at 6. Well, I guess I would increment to 5 before this pass.
Okay. And then lastly, again, what is the time and space of this function?
It would be same as before, still on time, since we're just doing a single pass. And
Okay.
constant space.
Okay. Yep. Sounds good to me. Okay. So there is one more follow-up here I wanted to ask. And maybe not surprisingly, it's about the same problem. Okay.
Right.
So we are again writing a function max profit, which takes in a list of prices. Right. Same situation. However, the restriction this time is that you can only do 2 transactions. Okay, and they cannot overlap, which means that again you can only hold one stock at a time.
Right. Okay, so we're limited.
So this one I want us to focus mostly on like a discussion, walking through what your thoughts are, and not to focus too much on optimal solution in this case.
Oh, okay, cool. All right, so we're limited to 2 transactions, which means so yeah, we definitely can't do this method where we're checking all the differences. Yeah, we shouldn't be here.
So I mean, again, we can just start with an example, right? Let's just start with the first one. Like a given example here, and let's talk about what the profit here would be.
Yeah, I guess. So if we're limited to 2 transactions, it should still just be the same, where we would take 1, 5, and 3 and 6.
Yep.
Our final profit should be 7.
Should still be 7. Yep.
And
how about for this case? I'll put it at the bottom here.
okay. In this case, I think it could just be 4. Or
Okay. Yep.
maximum profit should be 4.
It would be 4, but it would only be 1 transaction, right?
Yes, just a single transaction. So it would follow the same logic we were talking about before.
Yep.
All right. Alright, so you would have to consider the case where only a single transaction is needed.
Yes, there are. I mean, in this case, you could still use two transactions if you need. So like, don't overfix it on
Yeah.
that. But you only need one transaction in this case. Yeah.
Yeah. So I think we could go back to sort of the first problem we had, where we were taking the, I was taking the current minimum and taking the difference of the current values, and then using our current minimum, so we would go through the array.
Yeah. Okay, I think I see your intuition there. I think I see where you're going, but for the sake
Yes.
of time, I want us to disregard efficiency and use any way to come up with the correct solution. So let's not worry about that right now, and I want to just see how far we can get with just the correct implementation.
All right, so this, I mean, one way would be to brute force it. So just take.
Yeah, we can brute force it. Let's start there. It's not a problem to brute force for this kind of thing.
Right. Right, so to brute force, we would just all the possible pairs, I guess.
Mm-hmm.
So I guess we just start at like each value, take wait, how do we yeah, so I guess if we were to take like 7, for example, we would take the 7, find the profits for each of the values. So if we take 7, 1,
Mm-hmm.
As one possible combination, then we would take then we would skip those two and take a second pair where we would like 5, and then try with 5 and some of the other values as well.
Okay. Okay.
Yeah, but then we could just disregard 7 and 1, since that would be a negative value. So okay. So we just have to try all possible combinations. Do you want me to try and implement this in the code?
You can use a different function to implement that, but yes, I would like an implementation of any correct solution.
Okay. Then
So I here is presumably your choice for the first purchase.
Uh, yes, it would be the
Okay.
first purchase.
And so what choices do you have for the sale?
So it'd be all values following.
Okay.
So for int j equals +1, right? So it'd be the all following prices, and then profit should equal to the I.
Okay.
Oh, oops.
And then your
Sorry.
choice for the second purchase?
Then our choice for the second purchase would then be another here. And so this would be j +1. And inside there, we would have our second selling point. Right. Yeah. And then but then we'd be holding the same value. Good. So in this case, we have to ensure that the profit is being updated correctly.
Yep.
And so to do that, we'd want to take the we want to have a full max profit there. Our profit here. Right, and then so for each time we set both of them, our max profit should equal to the max of max profit and the current profit that we're trying to create or trying out each time.
Yep.
Right.
Okay. I see. Okay. Cool. Yeah, that makes sense to me. And just to wrap it up, let's talk about the time and space of this implementation.
Right, so the time should be O n to the 4, I guess, since we're doing for loops through it.
Mm-hmm.
And the space, space should be constant since we should only be holding this value. Or think constant. Would we have a distance each time? Yeah, it should be constant because we'd be holding one of these for each loop.
Okay. Yep. Okay. Anything else you wanted to talk about regarding this problem? Otherwise, we'll go into review.
Uh, nope. I don't
Okay.
think so.
Perfect. Sounds good. Great. Review time. I mean, first of all, how do you feel about the three kind of problems we asked today? They're all the same theme. They got
Yeah.
more difficult, obviously, as they went on. I want your kind of thoughts about how well you thought you did on the earlier ones.
I think I did all right on the first one, but got a lot of help on the second one. So,
Mm-hmm.
uh, yeah, I think I was basically given the answer, so I'm not sure if I can say I did well on that.
Fair, fair.
Yeah.
Okay, and I
Last
mean, one
problem.
thing you wanted to work on this time was more on the collaborative side of things. Like, do you have any read on how that aspect went? Like, not from like problem solving, but like from the other side. Yeah.
Uh, I feel like I can definitely work on more clarifying my thought process and
Mm-hmm.
explaining it in a better manner. I think it
Okay.
was more difficult since I was having trouble solving it as well.
Yeah. No, for sure. I mean, that is an important skill, right? Like being able to voice your thoughts
Right.
while thinking through the actual problem when you don't necessarily know what's going on yet. Or like, yeah, that's
Yeah.
absolutely a like a bottleneck for people. But yeah, I mean, we can definitely kind of get into it here. So I think keeping in mind that this is like a more like a standard problem. It's not meant to be like super difficult until the end. I think the first question was done relatively well. There weren't really that many, like from a technical perspective. I think it was quite well done. There was strong intuition about how you want to do the one pass solution. I think that was good. Again, like what you said is, when you have some confidence about what's going on there, it's good to say so. Right? Like, it's good to say, hey, I think I know how to handle this problem. I think this is the solution I'm going to take. Here are some concerns I might have regarding this approach, but I have an outline. Here's my thoughts. Right. I think if you
Right.
put those out, just lay those out as soon as you can. That's going to help for a couple of things. I mean, the first thing is that just putting thoughts down on the page helps you think through the next steps. That's the first thing. The second thing is if those aren't if your thoughts aren't correct, at least the interviewer is able to step in and kind of correct you right off the bat, right?
Oh,
So
right.
a couple of things I would say is like don't hold too many things in your head. Write stuff like even when the interviewer starts dictating the problem, I think that's immediately a good time to just start writing notes down. Okay, so that
Okay.
would be what I would say first is getting that down ASAP, right? And that's independent of any technical skill in that sense, right? So that's just like more of a
Right.
strategy or technique that you can adopt.
Okay.
Okay, so I mean, otherwise, there's not much to talk about in the first problem. That's pretty simple. That's just like kind of a warm up kind of thing. That I would expect to be a pretty standard like intern easy level kind of question. Okay, so that's kind of
Right.
that's kind of where that lies. The second question is more of a standard problem. Like this is what you would expect an average kind of difficulty to prepare for. This would be good, right? And this kind of problem is one which relies on you to observe patterns in the numbers, right? And so, in this problem, the main hint I gave was just how we can break it up into pairs and only consider pairs at a time, right?
Yes.
So for example, people who have taken or courses or maybe have seen these sort of problems before, seen the greedy algorithm, this is called, it's called greedy. If you've seen greedy problems before, if you've been introduced to greedy algorithms before, that would definitely help the intuition on this one, right? If you
Right.
haven't heard of greedy, if you haven't done it before, then it would definitely be more difficult, no doubt, right?
I see. Okay.
So, I mean, that isn't the only way to solve it. There's many ways to solve it, but that is typically the most intuitive one because it's easy to explain, it's relatively easy to understand. But either way, I think you could have probably done a bit more in terms of writing stuff down, trying different inputs, right? Exploring some ideas. Right. In this
Right.
case, I was given very little indication about what you were currently thinking about at any given time, and that
Yeah.
was something which made it a bit more difficult to guide you on because I wasn't sure if you were already thinking of something greedy. I wasn't sure if you were thinking of a recursive solution. Like there's many ways to do this kind of thing, right? So, it's difficult to match, your wavelength per se, if I don't know what you're already working on. So that's something to consider, right? To consider communicate on the communication front is to just kind of showcase what you're currently working on. And that's true even if, for example, if you were going to work on an idea that would be a dead end idea, that's still totally okay to show because at least the interviewer is given the opportunity to kind of direct you out of that if they so choose. Okay.
Yeah. Okay. That makes a lot of sense actually. Okay. Cool.
Great, great. And then of course about the third one. So the third one was asked because that would be a reasonable follow-up question for more difficult interviews. That would be a reasonable follow-up. So you might start at the second question and you might be expected to complete the third question, right? That would be like a more difficult interview, but that would be still within reason. Now, the third question is the progressive follow-up for this question because it relies on a different, like it requires you to recognize that the previous approach no longer works because you cannot buy and sell as often as you want, right?
Yeah.
And so you have to recognize that this is fundamentally a different problem, even though the wording is very similar. So the first kind of skill check there really is like, are you trying to rely too much on a previous solution? Are you trying to think too much about some greedy algorithm again? That's not going to work, right? And so there's many ways to tackle this. Typically speaking, when this is asked as a follow-up question instead of as a straight question, straight opener question, the idea is meant as follows, which is if you had done the greedy algorithm for the previous solution, you're meant to do an expansion algorithm on this one, which means instead of comparing things pairwise, you expand the pair to a triplet, to 3 to 4 to 5 to see how far you can get each pair, and you're only limited to two pairs, right? So it's a mindset, it's a way to think about the problem. Instead, for example, if you had done a recursive solution on the previous one, then now you would be expected to use memoization. So this one, depending on how you solve the previous problem, would be a way to apply an optimization on the previous one if you can't think of something novel, right? By the way, the
Right.
novel solution for this one would have been a dynamic programming solution, which is frankly quite unreasonable for the intern easy level, but that's okay. This is meant to just kind of help you think about what's going on. And oftentimes, by the way, this is something which people mistake sometimes, which is that, even in easier interviews, you still might be asked a difficult technical question, but the intention is not for you to get the optimal answer. It is instead for you to get an answer, or for you to get a correct answer, or for you to just talk about what ideas are possible, right? So
Right.
I want to here to dispel the myth that it's not always the case that the problem is meant to be solved optimally. That might be unreasonable in certain circumstances. So just keep that in mind.
Oh, okay.
Okay.
Cool.
In this case, this problem, obviously the expectation was not for you to solve it optimally. That would be too far fetched. However, one thing I did want to point out was that when you were, told essentially to just solve it in any brute force manner, um, that is something which interviewers would expect you to be able to crank out very quickly. Like if the problem is not esoteric, in other words, it's very understandable. Like you might not know how to solve it optimally, but you understand exactly how to do it in a human manner, right? Like in terms of giving a sample. Like
Right. Right.
when those are when that's the case, it is expected that you are able to code the brute force implementation very quickly, and that is
Oh.
oftentimes because, well, first of all, it's just a coding skill. Like, can you just code the thing, right? And the second reason is because, like, are you aware of like what's even going on? Like, yeah, you might not know
Yeah.
how to solve it, but are you aware? Or like, do you know how to catch the edge cases, right? Like, for example, like for example, in this case, one of the edge cases would be, you might not have a second pair, right? And
Right.
how would that be captured in your code? Right. So in your case, you actually have that correct because in this case, you wouldn't add profit if L was not accessible. That's correct, right? We didn't have time to ask you that, right? But in many
Yeah.
solutions, that might not be caught, and so even though someone is told to do brute force, they still might not be able to do it correctly. Okay, so when someone is telling you to do something brute force, and oftentimes, by the way, even if it's a simpler problem, you might still offer just to start with the brute force solution to see if you can think of anything along the way. right? And so what I'm getting at
Right.
here is that the brute force solution really is not something to shy away from, but it is something that you are expected to be able to implement quickly. And so it's really easy to practice sort of thing, by the way. This is unlike the other sort of algorithmic difficulties. If you want to practice brute force programming, just take any problem and just immediately brute force it. And for
Right.
any
Okay.
given problem Leetcode that's not like a really esoteric one, you should be able to implement the brute force within 1 minute. Like that's how long you should give yourself to implement the brute force solution. Because once it starts taking longer than that, first of all, it's a bad look, right? It's just a bad look to say that like, oh, this person's having like mechanical issues. Like that's not a good look, right?
Yeah.
Or it's also things like, oh, this person doesn't understand the question. Like why are they fluffing about this? Like this is like they already described it correctly to me. If they describe it correctly to me and they can't implement it, then they just have no coding skill, right? So
Right.
it's a case where like this is not something you want to fumble on, and it is a strategy you can use in other interviews to buy yourself time to think about other optimizations along the way, right? So brute
Right.
force, it is a tool, and if you're given an opportunity to do it, you should be able to seize the opportunity to do it quickly.
Okay. That. Okay. Yeah, that's something I'll have to practice then.
Cool. That's all the feedback for now. We still have a couple of minutes, so I want to open the floor to you if you have any questions about either today's problems or about like interviews in general.
Uh. Right. Just curious, were the first two implementations the optimal solution?
Yes, they were. The
Okay.
first, I mean, the time and space also is correct. I didn't mention that, but it's correct. The second one about the pairing, so
Yeah.
that one is correct. However, there are many different ways to do it, and so for
Right.
example, a
Right.
follow up would have been like, oh, do it a different way, right?
Oh, I
Um,
see.
so in this case, it was optimal. However, it might not be optimal under certain circumstances. For example, if you have to literally compare every pair, that would not necessarily be ideal. Um,
Yeah.
so it is asymptotically optimal. That's correct. However, it might not be like necessarily optimal depending on certain situations, and so you might be asked to implement like a recursive solution, for example.
Right. Okay.
And the recursive one would have been for what would have been basically what we had over here, by the way. So it would be a divide and conquer situation.
Oh, okay. Oh, oh, right. That was a big hint. Okay. And then, so as I'm solving problems as well, um, is it expected for me to first explain my approach and then start coding, or is it all right if I think
It's
as I'm
alright if you
coding?
start coding if you demonstrate confidence in your solution. Typically
Yeah.
speaking, it is expected that the level of interview is matched with the level of the candidate, which means that there is not a reasonable expectation that you can code it correctly in the first try.
Yeah.
And so the optimal play is usually to describe your approach and to call out where you think it might be incorrect before you start coding. But
Oh, I
there's
see.
nothing really stopping you from coding it straight up unless the interview is unless it's told up front the interview is meant to be more of a collaborative or more of a like a joint discussion sort of interview, right? So for Leetcode, yeah, typically speaking, we want to just see the optimal solution. We want to see that you can communicate and explain why it's optimal, that kind of stuff. But for other forms of interviews, like for example for object-oriented design or like low-level design or system design, those ones, then a lot more of the weight is put on the communication aspect because there's less obvious of a correct solution in those cases. So it does depend on
Right.
interview. For these ones, if you're very confident, you can just go right in. But I would say in general, you should hedge your bets and explain it up front.
Okay, that makes sense. Cool. All right, great. I think that's all for my questions.
Okay, thank you very much, Sean. Thank you for your time. Hope you see you around. Take care.
All right, great. Thank you so much. That's helped a ton.